Most people would look at this and see scrap, but inside these machines is proper industrial grade gear, and I brought both of them for $213.70. Today we're tearing them down to find out, are they scrap or a gold mine? I picked these up for cheap. I didn't expect much, but there's definitely some interesting stuff in here. So let's start pulling the machines down, see what we got, lay it out on the table, have a good look what runs these machines. Both of these are PCB conveyors, so they would have gone in a PCB factory. This one's just a single one. This one is a 4 PCB, so it has a top and a bottom on both sides, and it can go up and down with the ear rams. Right, got the machine, or the first one, pulled apart. So we'll go through some of the bits and pieces that we scored from it. I think we did pretty well for $100. So first sort of part we got, electrical wise, is a Meanwhile 24 volt power supply. So it's looks like a 2.2 amp power supply. So that'll come in handy for some projects. Decent switch, PLC controller, so these can be used for anything really. They use ladder logic, so I'll show you a bit of that later, but yeah, ladder logic, you set them up, inputs and outputs. Yeah, you'll find these in most industrial type machines. Couple of these cool little end stops. So these ones here, actually, it's the part number there. So these are adjustable, so you can adjust them using this here, and that'll adjust the distance that it senses at. Nice relay, so it's a 4-way relay, so you could have a forward and reverse, click it on, click it off. Power switch, so just your basic on-off switch. This is for the motor, so I believe it's a 1.2 microfarad capacitor, and that goes with the geared AC motor. So yeah, that's the motor there. These things are pretty torquey. They've got a reduction gearbox here. I think I showed that earlier. So that's the specs for that, and that's the specs for the gearbox. A couple of other electronical components. So we've got this here is a noise filter. So plug your power in, filters for noise for the AC voltage, and then a couple of these aviation plugs as well, which could come in handy. There's a really nice pressure regulator with a water trap on the bottom, and then the quick connect 90-degree fittings. Also a solenoid valve as well. So yeah, that's that's pretty cool. Electronic, 24 volts, so ear in, ear in, ear out, whichever way, in and out. Also, little ear ram. That's part number there. There's a very small stroke on it. Still pretty cool. There was four of these gears. So these are for the timing belts. So the timing belts are a V10 by the look of it. That's who made them. And then that's the length. There's also a longer one. Also these are a really nice machined lead screw. There's no backlash in that at all, so I'd say it's quite high quality. So yeah, that'll come in rather handy. Also got these ground 20mm rods, and then they've also got the bearing blocks that go with them. Again, very minimal like wobble and backlash. I think they'll be quite high quality. So yeah. There's also these little bearing blocks, so they just screw in, and then your lead screw or the ball screw, the lead screws or those other rails go into that. Nice bearings. Another bearing block, nice bearing on the inside. There's also some hex, so that'll be quite handy. I can make my own sort of screws and bolts and things one day when I build a CNC lathe. Cool little handle, so the handle pops out, do your turny stuff, and then just pull it out and it folds back in. And then, of course, we got the actual table itself. So there's all the aluminium extrusions, and then on the back there, these are all 3mm. These are all 3mm plates, so they'll come in handy. There's also wheels and feet as well, and the mounting for them. And then this here is a piece of 8mm steel plate, which is the top of the table. So all in all, for the first machine, pretty good score. There's also a whole bunch of miscellaneous M6 bolts, M5 bolts, sorry, all cap head screws, a few different bearings and pulleys and bits and pieces as well, and then more steel as well. There's also all the electronics stuff, all the wiring, and then there's also in there's also a rail for connecting. So all of this stuff's going to be pretty handy on the plasma cutter. So yeah, that's the first one. So quite a bit of cool stuff in there. Yeah, quite a bit of cool stuff in there. Obviously, if you're going to buy all this stuff, it'd be much more than $100. So I think I scored pretty well on that. And yeah, I think next we will crack into pulling this one apart. So again, in the back, we've got another, I think there's another 4 of these motors inside this. These same ones as this motor here. And then there's all the electronic stuff in here. So we've got, each of these has 4 relays. So 4 relays there, 4 relays there for 8 relays. And then there's another 4 of those same ones as before. And then the 4 capacitors for each one of the motors. There's also another power supply. And then there's all the air stuff at the back, all the rams up the top as well. So we'll get into pulling all that apart. There's a whole bunch more There's a whole bunch more of those optical sensors as well. So yeah, we'll get on to pulling this one apart, see what we get out of that.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah. Now that I've been put through hell, I never got anyone's help. I had to do it all myself. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always...
Alright, so we're back here on the teardown of the two PCB machines. So we've stripped most of the parts out of them now, as you would have seen before. Once I've got it fully, completely stripped down, I'll run through all the parts with you that we've scavenged out of it, and we'll see whether the $100 and something each was worth the money. Currently looking at the things that I've been able to pull off of it, definitely was, so there was a good score. But basically in this machine, or in this panel, we've got most of the control stuff for the machine. So starting at the bottom, we've got a big wire connector strip. So each one of these is just a straight pass-through wire. So you can basically have this short runs connected back to all your relays and circuits and things like that. And then they break out and go to your different parts from the other machine sensors. So your end stops, things like that. What we've got in this one is we've got two of those strips. So they'll be going in the CNC machine, the plasma cutter that we're building. We've got another 24 volt power supply, the same as the one that came out of the single line PCB machine. In this one we've got 4 relays. So as you turn this relay on, 2 of these front ones are normally normally closed. So basically with the power off to this relay, you get power out. And then when you turn this relay on, it activates these ones, which turns the power on. So I guess something you could do with that would be you could have a forward and reverse on there, and then you could have another relay to the actual power coming in. So you could essentially power this up, turn the relay on, power this relay up, and the motor would start going in, say, reverse. And then when you turn this relay on, it would cut the power off to here and it would put the power to here, which would make it go in the opposite direction. So these are quite handy relays. Over here, these are again relays. Each one of these in here is a relay, so there's 4 relays in each one, and they're only a one-way relay. So yeah, so I believe they're just a one-way relay, and I think these are only 24 volt relays. I don't think they're a 240. I'll have to check that. Then you've got your main power switch, so you'd flick that on. That would allow your AC current to come through. Then it comes in, breaks out, powers up your 24 volt power supply. Then the 24 volt power supply powers up your PLC controller. These PLC controllers are pretty cool. They're able to take inputs and outputs, turn on motors, turn off motors, lights, switches, whatever you need. They're not so much a computer, they're more of a like a microcontroller, I guess you could say. Now I've made a wee animation or a wee video to show how a PLC controller works. So if you haven't seen a PLC controller or you don't understand How they work in a ladder logic. PLC ladder logic programming. How industrial controllers work. A PLC programmable logic controller reads physical inputs like switches and sensors, executes your ladder logic program in the CPU, then switches outputs like motors and lights on and off. Ladder logic is modelled after relay circuits. The two vertical lines are called rails. Each horizontal line is called a rung, just like a ladder. Contacts are switches. The coil is the output. A normally open contact passes power only when its input bit is true. The switch is closed. Address 10.0 means input, byte 0, bit 0. A normally closed contact does the opposite. It passes power when the input is false and blocks power when it's true. The output coil energizes when the power flows across the entire rung. Q00 physically turns on a device like a motor or light. Initially, everything is de-energized. The motor is off. Pressing start closes the 10.0. Power flows across the rung and energizes the motor output Q00. The Q00 seal-in contact closes in parallel. This latches the circuit on. The motor is now sealed in. Releasing start doesn't matter now. The seal-in contact keeps the motor running. Pressing stop opens the normally closed contact 10.1. Power is broken. The motor turns off. We can use output Q00 as a contact in another rung. When the motor runs, it automatically turns on the indicator light. Every ladder logic program ends with an end instruction. The PLC scans all the rungs, then repeats. This is the scan cycle. The PLC repeats the scan cycle continuously, typically every 1 to 10 milliseconds. Input scan, program scan, output scan, repeat. This is how your ladder logic runs in real time. A TON, timer on delay, starts counting when its enabled input is true. The timer name is timer_1. When elapsed time ET reaches the preset time PT, 5000 milliseconds, the timer.Q output bit turns on. The timer.Q contact in rung 2 closes, turning on output Q 0.2, useful for delays. Example, keeps the conveyor running for 5 seconds. When the sensor input I 0.2 opens, false, the TON timer resets, ET goes to 0, Q turns off, and Q 0.2 turns off. These are the core building blocks for ladder logic. Master these and you can build any PLC control program. So this is one of the slides that came out. So this is where the PCB would have been tracked across. As you can see, there's a optical sensor there. Then on the back side, you've got the motors. Then you've got the lead screws and the rails that it slides on. So these here had a belt around it, and then you'd turn it, and then it would wind it in for the different size, whatever you were PCB size you were using. So I haven't pulled this one apart yet, but that'll be the next one to come apart. So yeah, it's pretty cool. I just thought I'd leave it as a full thing so you could have a bit of a look at it and see how this thing worked. Right, so in here we've got all the goodies that was inside this machine. So we'll start with this. Basically this here is a solenoid valve. It's got 2 outputs on it. Air comes in here, goes through the regulator to whatever pressure you set, through here into the block, and then out of this block you get your up and your down. And what that was controlling was these air rams here, which was the up and down of the one of these double units in there. So these also have a sensor, so it can tell the PLC controller when it's fully up or fully down. So that's pretty cool. To go along with that PLC controller, there's actually a screen as well, a switch emergency stop. So the screen is a touch screen, and you can basically set it up to have any of the parameters turn on and off, or up and down, or whatever you want to set, whatever you would normally set up in your PLC ladder logic. So we've also got, we've got 2, 4, 6, so there'll be 6 of these larger 20mm rails. So they also have the linear guide on them. Now these are obviously very high quality because there's pretty much no jiggle in them, and they move really nicely. Then these hex drives here were what was actually would drive the. So as you move the PCB in and out, the size, this would allow it to turn. So this was mounted to that block, and then the motor would be able to turn this, which then in turn turn the belts. So the belts looped all around this. So that's how they've done that, so that you can move it in and out but still have drive no matter where you are. Then there's these smaller rails. So these were the ones that went under there, and they lifted the whole unit up and down. So they're also really nice, quite tight, slide really nice, high quality linear rails as well. So they'll be pretty handy for something. A whole bunch of these bearing blocks. So these bearing blocks were on the ends of all of the linear rails and things like that, anything that moved. So they're just a plastic piece with a bearing inserted into them, as you can see. And yeah, really nice high quality bearings again. Everything on this machine seemed to be pretty high quality. I got ChatGPT to look up the price of one of these 4 stacking PCB conveyors, and it reckoned that this one here would be about 15,000 New Zealand dollars. So yeah, pretty good deal for $100. We got 4 of these. So these are an AC forward and reverse motor, very low speed, high geared motor, a lot of torque, and yeah, they're pretty cool. So that's what those relays would have been turning on and off. So it can, whichever way you have it on this, it'll run forward or reverse. So they're pretty cool motors. Another cool thing we picked up out of this machine is these lead screws. So these lead screws they're really tight. There's like no sort of backlash, so they're obviously high quality. Yeah, they turn really nice, big brass nuts on them, and yeah, they're pretty decent pieces of kit really. I would say they're probably like a 16mm lead screw. I'm not sure what the pitch is on that, but I'm sure I can figure that one out. So these could be handy for something, not sure. What else we got? All the motor mounts and handle mounts. So each handle had one of these, so you could wind the lead screws in and out, and then you'd have 2. So there were 2 lead screws on each side, so that it wound it in and out nice and evenly. So the handle was connected like that to one lead screw, and then the other one. So as you wound the handle in and out, the lead screw would move that plate in and out to set your distance for your lead screw. Then the other sort of score on this is obviously these enclosures. So these are all aluminium extrusion rail, heaps of bits and pieces. I'm thinking in here might build like a laser cutter or something in the future, be a good enclosure for something like that. So yeah, I think overall for the price I paid, I think it was like $213 or something for the whole, both units. The parts that I've gotten out of it are definitely worth more than that value. So if you're thinking about buying some random piece of machinery like this, just do it. If you're after parts and bits and pieces, like all of this stuff will get used eventually. But if not, it can sit in storage and wait for its opportunity. But yeah, other than that, I think I got a pretty good deal. Yeah, let me know in the comments whether you think I got a good deal, and yeah, thanks for watching.